Alright guys, in this video we're going to talk about how to get the most power out of your Volkswagen engine. The biggest bang for your buck. How to get the power at the top end or the bottom end, whichever you want. And go big or go small, depending on what you need to do. The best way to do this is to think about your engine as a pump. And that's basically what an engine is a VW engine is a pump of air and fuel. And the more air and fuel you get to go through that pump, the more power it's going to make. So if you think about it like this, I know this terrible little diagram here, but you got your big engine and you got your small engine. And a big engine, because it's bigger, if you were pumping, it's easier to understand this if you're talking about pumping a liquid versus air and fuel. Air and fuel doesn't have a volume that you can look at. But if you're talking about it pumping water, it's much easier to understand. So a big engine, to fill up this jug of water, is going to take less RPMs to do that because it's bigger. And think about it like a water pump. It's bigger, bigger, bigger. The bigger it is, the slower it can turn slower and still pump more volume of water. If it's smaller, it has to pump at a higher RPM to get the same volume of water to go through it. So it's easier to understand it if you think about it like water. That's the only reason I do it that way. It is a pump of air and fuel. So if you think about it like that, it's easier to understand the concept that we're going to go through in this video. So the guy says, hey, I can make a 1776 get 125 horsepower. Now that's a pretty good challenge. It's a little tough to do, but it's doable. Okay, I'm not discounting that, but okay, to get that much horsepower out of a small engine, you're going to have to run a lot more RPMs. If you use a bigger engine to do so, you can do it with less RPMs. So to build a 1776 that gets 125 horsepower, you're probably going to be up near or more than 7,000 RPMs when you get to that power. If I take the same combination, the 90.5, and I put a 74 crank in there, and I make a 1904, it could probably be done at between 5,500 and 6,000 RPMs. Now let me ask you this. Longevity of the engine, when you run more RPMs on that engine to get the power, which one's going to last longer? The answer is the engine that doesn't run as many RPMs is going to last longer than the one that does. So that's one thing. Also, the other thing is the power at the lower RPMs is going to be larger with the bigger engine. It all depends on how you engineer it, but for the most part, a bigger engine is going to have more bottom end torque than a larger engine. So this is why I always say, when you can, go bigger if you can. And again, remember the threshold of pain is always problems like budget. So if you're going to go larger than 92, or if you're going to go to a 92 or larger head with a 74 or 76 or even 74, I kind of stop it there. Then you're going to probably need a larger combustion chamber head, which costs more money. It all depends on what you have in your budget. So like if you've got an old stack of heads like this and you've got access to valve grinding equipment, then it costs you nothing to go to a 74 by 90.5, or hardly anything. But if you have to buy heads anyway, then it's not going to cost you that much more to go to a bigger engine. So that's why if you need a case, or you have to get all your case machined anyway, and maybe you don't have a very good case and you got to go with an aluminum case, brand new one, then it might be the time to go to the 82 stroke engine. Just remember, with your 82 stroke, you will need a clearanced camshaft for sure. But you can always go with the 78.4 or the 78. It's another option. You get a pretty darn big engine with that. The aluminum case is going to eliminate, of course, a lot of your issues that you have. One is case wear. because remember, they have shuffle pins on the center mains, and you might be able to get away with aluminum bearings versus you really need steel back bearings with the mag case if they're not available. Of course, they have been available. CB Performance is advertising that they have steel back center main bearings, if you're wondering. I don't know what sizes. They might be very limited. The other things that are really important, if you go really small and you're trying to get a lot of horsepower of the engine, you might have a RPM range that's more like a two-stroke dirt bike. Because to get that horsepower at the top, typically you've got to have a pretty good sized camshaft. And things to remember are the larger the cam, the least the bottom end, the smaller engine with a big cam in it is really going to have a non-existent bottom end, not as much power down there. It's going to have more power at the top end, and so you're going to want to be in it all the time. If you build bigger, it's much easier. You have power down low, you have power down high, up high, you have it all over the place because it's just a bigger engine. More displacement's going to give you more torque. It's just a no-brainer to me. And that kind of tells you why that I like to build the 74 or larger. And remember, the 74 kind of shares with the 74 with the short rods. A lot of the concerns of people are like, hey, I don't want a wider engine, my stock engine. So 74 with the 5325 short rods is typically around the same width as a stock 1600. Really no difference. It just doesn't look any different on the outside, but it's much meaner when it comes to torque and horsepower. The 74 millimeter stroke engines have counterweighted crankshafts, and really don't cost much more to build. There's almost if you're thinking $100 is a significant amount of money, honestly, you're way out of the realm of building a Volkswagen engine. These things cost thousands of dollars to build now, and you add $100 to it, and if you can get something that lasts longer and gives you more power, that's always a no-brainer to me. So again, the easiest way to get the most horsepower is engine size. Bigger is better when it comes to horsepower, but there's issues with it. Remember, I say there's a cutoff when you get up to past 74. Some 76s you can do fine, but once you get to 78, that's when you need to consider things like shuffle pins. If you go to an 82, that's when you're going to have, a wider engine. It may not be what you want, may not fit in your car as well. Those are things to think about. Now, if you're just going balls to the wall and you go to 2332, which is an 84 stroke, or an 86, 2387, you run into a whole slew of other things. I think we're going to have those things in a separate video. So going really big, you can get a lot of horsepower out of a bigger engine, but there's definitely issues. You're going to have rod ratio issues on this 2387. We'll talk a little bit about that later in the video. Again, you can build the 74 with B pistons and 5.5 rods, and you'll have even more power by doing that, but it does cost a little more money for those pistons. So generally, I don't normally do them. It is a little bit better, but that's up to you. You don't have that option, again, with the 88s. The 88s are only available in 8 pistons. I don't think they make an 8 piston other than even 85.5. I don't think they make it either. So you have to get a 90.5 case or larger to do that. So let's get to the next area. The next thing we're going to talk about is flow. So if you can take the same size engine and you can get the water to flow through it faster and easier, it's going to get you more power. The same concept as what I was saying about water pump. So flow is a huge thing to add, but with a smaller engine, you're going to need more RPMs to get flow than you will with a big engine. Simple. So to get flow, one of the things you can do is you can increase the size of your ports on your heads. You can increase the size of your ports on your exhaust ports, your intake ports. You can go with larger valves. The easiest way again to do that is either get the Panchito heads from CB Performance or to get the AA Performance heads, more of a budget friendly one. They both work really well. I've had people say I don't like the AAs. I've had nobody say that they don't like the CBs. But, you know, the AAs, of course, are made in China, a little cheaper. But I've had good luck with them. I know a lot of guys who've had good luck with them. But you're going to hear positive and negative from a lot of different people on that. The improved heads, I think, are so worth it because the spark plug has more meat around it. There's more threads on the spark plug. These old heads were always prone to cracking between the exhaust valve especially and the spark plug. Sometimes they'd crack between the exhaust valve and the spark plug and the intake valve and the spark plug. It was a real common thing, and once they do that, they're no good. They're going to be a problem forever. So at that point, it's time to throw the heads away, get a new set. So that's why all these old ones are diminishing. And people go, oh, I want the old German ones. Well, you know what? Even the new China, in my opinion, the new China heads from AA are better than an old set of stocker ones, all right? And if you get them already from them, they come, both people from CBN from AA, they both come with stainless steel exhaust valves. They both come with single high rev springs. By the time you add the cost of buying new valves and putting new springs in and having the heads machined and all the other stuff that you can end up doing with an old set of heads, you're going to be basically at the cost of a brand new set of heads. So you might as well just buy new ones. It's already done. Now the difference between the AA and the CBs is the CBs come with an enlarged combustion chamber, but it's not 60 cc as far as I know. I don't remember the exact numbers on them offhand, but they're not 60 cc's. The AAs come 60 cc's already. They come at 90.5 if you want them. You just order them and they come already done. They come at 94 if you want them that way. You don't have to have them machined, but they are 60 cc. So sometimes you have to make the combustion chamber smaller depending on the engine size you're going with. That's why you want to estimate, always measure your cc's because it might be a little different every head. But that's why you want to estimate, okay, in the CB Performance engine calculator, before you start buying parts, estimate your combustion chamber size and estimate your, the shims. I like to try and do mine at no more than 60 thousandths deck height. If I can go tighter, I definitely will. And then I'll put a step cut here in the head, like what's here. That little step right there, that's not stock. They're usually just flat all the way across. That little step, and I'll have that step machined to exactly what I want the want my shim size to be, and I'll do that way sometimes, and just run the cylinder right on the head and run my deck height to 0 even, or very close to 0. So I'll use the combustion chamber in the cylinder, which is basically the better way to have it fire. If it's firing inside the barrel, it's not going to be as efficient as if it fires in here. That's going to give you more power. It's going to give you less detonation. Always a better run to try and get the fire to happen in the combustion chamber. Another thing to get better flow, exhaust system. But you don't want to go too big on your exhaust, because if you go, the bigger the exhaust you go, the higher the RPMs are going to be to give you flow. If you go too small in the exhaust, you're going to get massive amounts of torque, and it's not going to bring power at the top end. So you need all of your parts. So let's say you put a really big cam in it and you put a really small exhaust. Those two things are not going to work together. It's all about combination. You need to have, if you're going to go really big on the cam, that means you're going to have top end power. That means you're going to go bigger on the exhaust. Okay, you follow me? But it's going to fall on its face on the bottom. So if you don't want that, then go smaller on the cam and go small new exhaust. Okay, so valve size and exhaust kind of need to work together. I think this one is an old merged by 4 tuned. It has a 4 in the side of there if you can see the weld. So that tells me that it's probably a 4 tuned. I don't really know. Another guy said it might be something else, but I think it's 4 tuned. These were really good back in the day. This was one of the first merge systems. And these, what they do is some of these merge systems, they have different ones now. A1 makes the best merge system that you can buy. There's no doubt about it, but they are not cheap. So some of you guys are going to go, oh man, you know, that's like half the cost of my engine build. Okay, if you want the most power, you're going to pay the most money, but one like this will work really good. This is a, what you see here, this collector, how they're merged together. This is creating very high flow. And when you, not only is it the exhaust size, but the collector, the way it's shaped like this, when one cylinder goes across the other, what it does is it creates a vacuum. So when your exhaust goes through, okay, every time it fires, in front of the fire is pressure. Behind the fire is vacuum. And some of these companies like A1, even the AA Performance one, it works, but it's not going to be nearly as good as the A1, okay? And if it's what you can afford, they're fine. I use those on mine. They work good. But what happens is when they go across this merge, is the vacuum after the one fire, because of the way it's shaped and everything, and the lengths of the exhaust tubing, it helps pull the pulse. The vacuum side of it helps pull the power, the pressure side through this collector, and that's what gives you better flow. And then again, this is 1.5 inches, so if you had like 35.5 valves, that works great with an 1.5 inches. So you can run one of these on as little engine as a 1776 and actually get power with it. But again, on a 1776, it's going to be at the top end. So if you want to get that bottom end power, I mean, what are you going to spend for a 74 versus a 76 counterweighted crank? It's going to cost you basically the same amount of money. So if you go with a 74, you're going to get more torque, so you can get more out of the bottom end, and now you can still get that same power in the top end, and you're going to be using Porsche technology, because the 74 was what they used in the 912, okay? And they used 74 with 5.3, I think it's 5.354 rods instead of 5.325, so they're just about 27 thousandths shorter rod. It's really not much different, okay, if you go with the short rods. We'll talk about rod length in a minute, and that can give you more power to have longer rods. It also can make the engine last longer, but there's good and bad to it. It just depends on, again, your money, your budget. So if you go too big on your exhaust, and your flow isn't going to happen until higher RPMs, so you're going to lose bottom end. 1.5 inches is a nice combination for a lot of different engine sizes, up to about an 82, even a, well, if you get up to a 7, right at the threshold is kind of the 2180, a little bit bigger than that, the 2276, and you kind of get to where you might want to have an 1 5/8. It depends on where you want your power. If you're going to put it in something light, you can go with 1 5/8 on those, and you can get more top end power. But you're going to lose the bottom end a little bit on those engines. You get the 2387, 2332, you're going to want to have bigger valves usually, so you're going to have the 44, whatever they are, 44 37s, and then you're going to want to have the 1 5/8 exhaust. At that point, you kind of run into that, oh, you just got to go there. When you start to go to those bigger ones, there's a lot of more issues with, you're going to have to get your cam trimmed, you know, Rod length becomes an issue. We'll talk about rod length now and get on with it. So when you get into a bigger stroke, okay, the bigger the stroke, generally the bigger the rod length. The reason I like the 7374 with the 5325 rods, it's very similar to Porsche. I figured that that's a safe range to be in. So this 5354, I think, I can't remember, 5352, I don't know, the Porsche rod length is just a little bit longer than the 5325. So anyway, rod length. The longer the rod, the more power and more top end you can get out of the engine, believe it or not. And it's because of the angle. If you see here, the rod angle when it's going down, if it's longer, it does not push to the side of the barrel as much. It pushes more straight down because the angle of the rod is more, when it's longer, if you can just imagine, it's more straight up and down and there's less movement back and forth. When it's shorter, it has to go this way and this way, and that creates power loss and a little bit of engine wear. I mean, is it significant? Again, that's why I said the 74 was okay with the Porsche, very similar things, and they weren't worried about it, so I figure I'm not either. But there's a lot of guys that'll say, no, I don't want to run the short rods because, I'm worried about my piston skirt wear, and, is it an issue? I really don't think it is. I mean, how many miles are you going to put on your car? You're looking to get, 300,000 miles out of your engine. Probably you're not going to put more than 100 on it in your lifetime. I mean, I don't know, unless you're daily driving it and all that, I doubt that many people are going to do that with these old Volkswagens. So the issue is it's a bit vague to me. So, okay, except when you start getting into the longer strokes. So if you go up to 82, you can do, I did a 78 short rod and it was easy. Okay, 78, B piston, short rod becomes about the same width as a stock engine. That's why I like to do it sometimes that way. If I want more power, I'm going to go with a longer rod. Go 5.4 stock length, 5.5, and then you end up with a giant barrel shim. 82, you might have to go even more. You might have to have lengthened barrels. I'm not sure on that. That stuff I don't really build, because the reason I build the smaller ones, the ones up to a 70, is they're much cheaper to build. I would have put a 82 in my bus, but one of the reasons we didn't go 82 is I forget, it was like there was not all the parts were there. Like I went with a 1904 instead of a 1968. Or no, a 2007 versus 21. What's the next one size? I'm not sure. What's 2174? I can't remember. The next size bigger, 20. I can't remember the number. But anyway, the next one bigger is because they didn't have heads in stock for that at the time. I remember. So I stayed with the 90.5s because I had some 92s. And I bought the thick wall barrels and everything, but they just didn't have any heads. And I didn't want to go out and take brand new heads and have them machined. It just didn't make sense. So I went with the smaller engine. So again, those are all factors you might have in play when you're trying to build yours. You can't get the parts you want. That happens too. So you might go, I want this, and you can't get it right then, or that happens all the time. It doesn't need COVID for that to happen, guys. There's always supply issues in VW parts. So anyway, rod angle. The longer the stroke, the longer the rod. You can look up things on rod ratio, okay, and it'll help you understand some of this stuff. I would encourage you to look into this stuff and find out about these things, because rod angle can be a problem, especially when you get into these big engines like the 2332, 2387. You're talking about a really long stroke, okay, and having those longer rods to keep your rod ratio so that your engine can gain more RPMs to get power, because that's usually what these guys are doing in racing, is they're using the big engines, the 2387, 2332s, and then they're you know, having to get them up to near 10,000 RPMs to get, you know, 9,500, 9,300 RPMs, somewhere in there, to try and get more horsepower, because they're trying to get more air and fuel through that engine. And that way, they're maxing all that out. They're getting as many RPMs as they can, so they're getting that pump to run really high RPMs, and they're also getting it to be very big and have better and have more flow. So that's the whole game when you get into the big motors and the big horsepower, is to have it do it. You're going to have to do it with a lot of flow and a lot of engine size. But again, you run into the rod ratio issue. You'll kind of see these things in forums on the Samba, and it's because when you start to get to those, you start to run to, I think it's a 1.5 or less rod ratio, and you just can't really, it doesn't like the RPMs, so it won't even get to those RPMs. I don't know exactly how that works in the engineering world, but I'm just saying there is that issue. Okay, so I like to, you know, with the smaller ones, if you go up to 78 or less, you know, you can play around with the rod, any rod pretty much you want. But if you start to get up to 82, that's when you kind of go, well, I better put bigger, longer rods in it. I don't think I'd do an 82 with short rods. I think the rod ratio isn't that great. I'd rather have it be like 5.5s, 5.6s or something, you know, something bigger than what's in there. So anyway, so if you want to think about play around with rod ratio, the longer the rod's going to give you more power. So that's just the way it works. As far as the shorter the rod, you can get more. It's lighter weight, so there's that. You know, less rod length is going to be lighter. So you know, you have to. Those are all factors you play with and think about. But to get the most power, longer rod is going to do it. Because again, it pushes the piston straight down, not at a little bit of an angle. All right, especially when you get it in those really high RPMs, having longer rods is really important. Now, food for thought, if you guys have a little more money, CB Performance likes to build a 74 with 5.5 rods, longer rods, so that's going to give you more power, right? So if you're looking for RPMs and power, that might be a way to do it cheap. 74 longer rods, or even 76 long rods. Okay, I don't know you'll end up with the cylinder shim, and then B pistons, and so you end up with 74 long rods, 5.5 rods and B pistons. I believe you end up with around stock width engine. So it's a little more expensive to do because the B pistons are a little more money. But it might not be too bad because they have a really good price on 5.5 rods. Look on their website. CB Performance has some good deals. Couple things to look at on CB Performance website is 4140 crankshafts, 74, and they have a really inexpensive clearance rod. I haven't used them yet, so I don't know how much more you're going to have to machine out of here to make them work. The rod bolts look a little bit bigger, so I really don't know. I haven't run them, but they do have them on their website, and I know that they work because they sell them. So, and CB sells good stuff. So anyway, they have those, the longer rods, and then you can go with B pistons and build that 74 90 by 90.5, which would be 1904. You could do it that way, and then put dual carbs on it and some big heads on it, or go to the 92, and build a 21 or 1968, and that would be fairly inexpensive to do, and then put dual carbs on that, some 40s on there and create good flow, go with bigger valves, better flow, port those heads. That could be a really good, inexpensive, with good bottom end screamer. I mean, you could build something really fast probably by doing that. So just food for thought for an inexpensive build. I mean, if you've got the money, just buy the bigger engine, you know, and you got the space inside your car, the bigger engine is going to give you more power. All right. So anyway, I figured I'd just make a video on this subject because I know a lot of people want to build something to get good power. And this will just kind of give you those tools and things to look for and things to read up on and stuff like that to get to know about how to make your engine go fast. All right. I'll talk to you in the next video. Please like, share, and subscribe.